We are the Sustainable PPE Design Team. Hailing from across the globe, our team is tackling the global problem caused by biological and material waste during the COVID-19 pandemic, from the unprecedented consumption of personal protective equipment. From a set of diverse backgrounds and experiences, our common goal is to keep people and our environment safe. The guiding question behind our project is, what does it look like to create a more sustainable alternative to single-use PPE? We're a team of 5 people from around the world with varied specializations in science and technology. Our experience includes multiple disciplines across engineering, science, tech, and most importantly, medicine. We came together remotely through Stanford's Frugal Science class to find a way to contribute during this pandemic. Through our research, we discovered that doctors and nurses normally wear one PPE kit every day, which is single use, while they're working with COVID patients. At the end of the day, this kit is discarded and it's turned into biohazard waste. And that waste is either taken to a landfill and buried, or it's taken to an incinerator and burned. In either case, it's wasteful and harmful to the planet. And our team wanted to answer the question, can we save lives while also saving the planet? During the pandemic, there have been PPE shortages all over the world. The map on the left shows the shortages just within the United States. And in countries with lower resources, these shortages are more widespread and more expensive. Decontaminating PPE, which is reusable, appropriately and effectively, costs money and time that healthcare workers don't have. And using single-use PPE and then discarding it at the end of the day is wasteful. In India, about 200,000 single-use PPE kits are used and discarded every single day, and that comes out to about 6 million used per month at 1,000 to 2,000 rupees of cost per kit. This comes out to a cost of $82 million US dollars per month to the Indian healthcare system.
So we identified two major pain points with the current single-use PPE. One of the major challenges in the treatment of COVID-19 patients has been the disposal of personal protective equipment kits used by doctors, paramedics, and nurses. By July, Mumbai had generated a total of 12,000 kgs of COVID-19 waste on an average day. That's just from one city in India. What about the entire country, the entire world? The figures are just overwhelming. In a real-world setting, errors in PPE doffing result in accidental contamination of the wearer, which creates the potential for cross-transmission of pathogens to other patients. With long work periods and exhausted healthcare workers, these errors are on a race, which in turn negate the very purpose of wearing a PPE. These are a couple of things proposed in the past to address the issue of mounting PPE wastage. One of them is a UVC decontamination chamber, but we had to refrain from it as the chambers needed to be really huge, making it expensive. And we were unsure if the decontamination was effective owing to the folds and creases on the gown. Washing the gown with soap and detergent was something we stuck to as it was universally available and inexpensive. For this, we needed to identify a material which would withstand multiple cycles of washing without losing its properties. Our main focus is still to come up with a biodegradable material which would fulfill all the requirements of a PPE, but this needs a lot of research and testing and would take time. So we decided to take a two-pronged approach to develop a common PPE design with two different fabrics, a reusable one and a biodegradable one.
Our team proposes a multifaceted approach to tackling the challenges of sustainability and reusability with regards to PPE. After a lot of brainstorming, we have focused our solution space on redesigning PPE. In terms of tackling reusability, we have decided to make a new PPE design, which would make it easier to don and doff. We have observed that PPE is not commonly reused because of the risk of contamination while donning and doffing. And hence, our goal would be to create a design that is easy to don and doff in such a manner that the risk of contamination is reduced. We are also aiming at getting a biodegradable material to make this design. This would mean that the PPE would be easier to don and doff, but at the same time, it would also be biodegradable, which means that the waste does not pile up in landfills. During our research, we came across some interesting materials which have unique properties that can make them promising for the use in PPE design. Lyocell is a man-made, completely biodegradable fiber which is made from a wood cellulosic pulp. It appears to be a promising option for the design of PPE because it is soft, breathable, light, and comfortable. The fabric has a controllable fiberization, which would ensure a variety of designs to be stitched. Sea cell is a biomaterial which is manufactured from brown algae. It is breathable and hence has the ability to retain the nutrient content of seaweed. However, our team decided to rule out this fabric as it is very highly expensive and not easily available. Jute is a fiber which has a very high mechanical strength and can be used for a number of purposes. However, jute does not have a very high wetting strength and therefore loses its mechanical properties when it is wetted or exposed to water. Chitosan is a biomaterial that is made by the acetylation of chitin, which is a derivative of crustaceans and fungi. The material has been proven to have antimicrobial properties. This brings me to the next material which our team considered, which is a jute chitosan blend. A jute chitosan blend is basically a material which combines the favorable properties of both jute and chitosan to get a sustainable biomaterial that can be used. While jute on its own has poor wetting strength, adding a layer of chitosan to it can make it have a higher wetting strength, which would mean that it will retain its properties even when exposed to water. The jute chitosan blend has antimicrobial properties and hence could be very valuable in the solution space that we're looking at.
Here we compare isolation gowns with coveralls. Some of the advantages of isolation gown include a low risk of self-contamination during doffing, less expensive, more comfortable to wear over longer periods, and quicker to don and off. And some of the disadvantages include no protection above the neck and below the knee, because of which the wearer would feel less secure or less protected. Compared to this, for coveralls, the main advantage is it covers the entire body and the wearer feels more safe and protected. And the disadvantages include a higher risk of contamination during doffing. It's more expensive compared to isolation gown. It's uncomfortable when worn over long periods, and it's time consuming to don and doff. In our first prototype, we designed a gown made up of a waterproof polyester fabric with a loop near the wrist, which would help in quick doffing, thereby preventing accidental contamination. In addition, the gown would be directly sent to the laundry for washing without the need for reversing the sleeves. We are currently working on prototype 2, which would include a hood as well as a series of snap buttons at the back and would become a hybrid between a coverall and an isolation gown, taking the advantages of each and overcoming the challenges associated with them.
We know that in order to bring this product to reality, we're going to have to consider things like feasibility. Firstly, we considered the raw material cost and found suppliers that would be able to provide not only the jute and chitosan, but as well as the lyocell material. We also found ways to leverage existing manufacturing infrastructure to be able to produce our product, primarily through the identification of the Budge Budge Company Limited, as well as the Bangladesh Jute Mills Company that would have the necessary processes and industrial technology to be able to produce a product like this with slight modifications. Finally, in order to distribute our product and get into the hands of people who need it, we've identified potential pilot partners through a personal connection of our mentor, as well as we'd be able to apply to open calls for PPE that local governments put out who are in need of PPE. After this class ends, we know that there's many next steps that would be needed to take our product to reality. One of them includes designing an design iteration on the PPE design by running more mini experiments on the donning and doffing procedure and considering additional form factors for users. We would also conduct material tests. By conducting more experiments to back previous work done on the efficacy of jute and chitosan, we can ensure that not only are we choosing the right biodegradable materials, but ones that will protect people and be up to clinical standards. We would conduct early prototyping by using the selected biodegradable materials in the form factor that we need, and by testing and getting feedback from the open source frugal science community, we would be able to open source our product and ask people to conduct mini experiments and iterate on the design themselves. Finally, by working with manufacturers and suppliers, we'd be able to take this final, well-feedbacked and well-tested solution and scale up production and manufacturing.
We'd like to thank our mentor, Dr. Nichole Starr, for her help on this project, along with our professor, Dr. Manu Prakash, and our TA, Tyler Chen. If you're interested in collaborating with us or in building upon the work that we've already done, you can click on the link on the slide, which will take you to our Notion page, where there's more information about the research we've done in reusability and sustainability, and there's also information about our next steps and our future plans. You can also reach out to us through Discord or through email. Thank you.